Good afternoon, everyone. We're here to talk about the InHand Networks products and solutions for Internet of Vehicles. My name's Tony Lee. This is me. My phone number, email, in case you have any further questions later on or have ideas after the Q&A session later, please just reach out to me directly and I'll do what I can to get you the answers that you're seeking. Here's our agenda. We're going to have a little bit of a brief overview about InHand Networks. We're going to have the introduction of the VT310, which is our new addition to our family of telematics devices. We're going to discuss the VG710, which is our flagship product. And then we're going to go over a little bit of applications. We're going to have a selection guide and roadmap covered, and we're going to try to handle a little bit of Q&A as well. Here's a little bit more about InHand Networks. We were founded in 2001 as a pioneer of the Internet of Things. If you note there, along the way, we've worked with some of the who's who of automation, IoT, and we've had an amazing trajectory over the years. GE Healthcare is one of our customers. We're a Schneider CAPP customer and a Rockwell product partner. Siemens, ABB, Eon, everyone who's anyone in automation does work with us and knows us. Last year, right before the in 2019, we finished construction on the new factory. 2020, we actually joined the STAR market, which is the Shanghai Stock Exchange equivalent of NASDAQ. Just really, really interesting and fascinating growth over these last 19 years. We're a truly global company. We've got locations in North America, South America, Europe, Asia Pacific. We cover everywhere. We have over 300 employees, and what makes us very unique in the IoT industry is roughly 1/3 of that is R&D. We have a very, very, very heavy focus on R&D here at InHand. 2019, we did over 40 million in sales with over 390,000 devices shipped globally. We do have a commitment to quality and support. ISO 9001, 2015 ROHS, and CE certifications. A 3-year warranty, which is very unique in our industry. In IoT, most products are a 1-year warranty. Our stuff's good, and we stand behind it. And then also we do offer free technical support 16 hours a day, 5 days a week. That's incredibly unique in the industry as well. Here's a little bit about our different forays into the IoT and M2M product space. We work with application layer, such as our IWOS wireline solution for monitoring and predictive analytics of the power grid. We do smart vending control systems. We work with different platform layers. So we have our cloud platform here with Product Manager and also InConnect, our VPN solution. We do the network and product hardware layer where we're building industrial cellular routers, Ethernet switches that are industrially ruggedized, cellular modems, edge computing gateways, and what we're here to talk about today, the vehicle gateways and the GPS vehicle trackers. And then also we work with a variety of different sensors, PLCs, and so on and so forth. Let's dive into the Internet of Vehicles, shall we? Here's our mobile connectivity solutions. First of all, here's the InVehicle T310 Tracker. This is the product that we're going to be focused on for the majority of the conversation today. This is our foray into heavy equipment, generators, trucking, you name it. this is kind of the telematics equivalent of the Swiss Army knife. It's going to get everything done for you. And then we're also going to talk some about the InVehicle G710 Gateway. This is more of not just the telematics device like the T310 is, but it's also a fully functioning high-end wireless access point and router as well. So this is more directed toward, let's say, the public vehicle environment. So buses, trains, things of that nature, but also first responders, private bus and transit solutions, so on and so forth, where you've got more people, more things on board, and therefore a greater need for more diverse capabilities. So let's start on the VT310. This is our ruggedized product foray into the market here. It's IP67 ruggedized. It uses GNSS plus GPS plus an inertial sensor, so an accelerometer on board. We do have CANbus, a diverse array of IOs, and even one wire for it. We've got CAT1, CAT-M, wireless technology for here in the US. So you're going to cover all of the carriers in North America with this very easily. And we do work with all of the commercial telematics platform providers out there who will work with us. It is an open interface that we will allow any telematics platform provider to integrate to. And it's a relatively simple one at that. And then obviously we have, FCC, CE, PT-CRB certifications, as well as carrier certifications coming along as well. It's a very low power device. It actually, at max power draw, is 0.77 watts. Part of that is because of the CAT-M, CAT1 area. And then it does have a 1200 milliamp hour rechargeable backup battery. There are a lot of telematics devices that are out there in the field right now that operate on a supercapacitor type solution. So actually it's a last gasp, where and when the ignition was turned off of the vehicle or the machine, and they're drawing all of their power off the CANbus. We actually continue to work after the fact so that you actually know where the heck things are. It's a way to make sure that if something's off, and let's say it's on a trailer and it gets moved, you as the fleet operator don't get a surprise later on when your machine turns up potentially many miles away. A little bit more about our extensive integration capabilities that I alluded to earlier. We support single or dual CANbus, both J1708 and J1939, as well as OBD2. We've got a robust number of I/O options out there. We've got 4 digital inputs, 3 digital outputs, 1 analog input, and a 1-wire interface as well, so that you could integrate something like, say, a Dallas key interface or something like that. For those who don't know about what digital inputs are just a detection of an open or closed line. So you're going to know, for example, if a door is open, a door is closed, perhaps a switch is flipped that's connected to a PTO on a specialized piece of equipment like a street sweeper, things of that nature. Digital outputs mean that you can send wirelessly to the device and then control a switch there to turn something on or off. So your digital outputs might be connected up to, say, for example, flashing the lights, honking a horn, taking ground off the ignition for an anti-theft purpose so that the vehicle wouldn't start again once it's turned off, or it won't start in the first place. Analog inputs, that's where you're going to have a resistive value to know where you're, it could be something as simple as a float fuel sensor if it's on an older piece of equipment that may not have fuel economy built into the CANbus, for example, or who knows what else. There's so many diverse applications in the telematics field just based on the diverse types of diverse number of equipment, vehicles, and use cases out there. We also have onboard Bluetooth. And then we have the ability to connect to a variety of different peripherals through this interface, whether it is the digital IOs, the Bluetooth, so on and so forth. So that could be to a data terminal, a variety of different sensors, controllers. The fact is, we make it easy to integrate and build our product into your existing systems and processes. We have a 31-channel GNSS. It's GPS, GNSS, and assisted GNSS, which means cellular network assisted. And then obviously we've got the inertial sensor as well to know so that, for example, if it's going through a tunnel or something like that, we can provide direction and know where it's continuing in that same direction inside the tunnel, and it's going to pop out on the other side. We've got real-time status monitoring capabilities as well. Again, there's the onboard gyro, tells you what's going on there. You've got an accelerometer so that you know if you've got harsh braking, harsh acceleration. And then obviously the monitoring and analysis, that's going to be through your OBD2, J1708, or J1939. Again, single or dual CAN, which is unique. Very few actually support dual CAN J1939 at this point, but that's the new standard that's coming out. Basically what you're looking at here is you're going to have all of your information, so you know if the guy's harsh braking on the vehicle, if he's taking curves around corners, you know, a lot faster than what he should, where you might have a tip over risk with the vehicle, dangerous driver behavior. But then you're also having real-time data acquisition for the tracking and monitoring of that vehicle or equipment, so that you know, is it being used, how is it being used, where is it being used? And then obviously the preventative maintenance aspect, where we're able to send this information all combined to the cloud for a third-party application to read that data, analyze it, and provide such information as engine hours, any diagnostic error codes that may have been thrown on the bus by the ECM, or some companies are even getting into the predictive analytics and notifying that you may want to check that there may be something that could be taking place in the near future. You know, hear the sneeze versus do the $50,000 autopsy after the fact when it's too late and you have a lot of downtime. Got integration with software. Obviously, we are a Microsoft Azure partner, so it is fully compatible with the Azure IoT Hub. And then we have our Flex API, which provides easy integration to any third-party platform out there. The T310 is designed to work where you need it. You know, InHand's background is in industrial automation. We understand harsh environments and harsh requirements on IoT devices. So the T310 operates in all 9 to 48 volt ranges. So all vehicles, all equipment is covered, even if it's something that is very, very large, or it may have solar power involved, or it may have a large electrical system associated with it. We've got a very, very broad operating range, -20 to +60 Celsius when it's connected to power, but it's also -20 to +60 Celsius when it's powered by the internal battery. And then it is IP67 rated, which means it's designed to live in really nasty conditions. Here's a little bit about the VG710 as well. VG710 is our high performance vehicle gateway. This is the one that we were talking about, I mentioned earlier. PTCRB, FCC, cellular carrier certifications, everything's there. It's got a high-speed 4G LTE connection on board. Currently, it is CAT6 LTE, which is part of the LTE Advanced. You've got gigabit or standard Wi-Fi. Both are there. You can use either one. It's got an A7 quad-core processor, Inertial navigation, same as the T310. It handles CANbus. It's got a diverse number of IOs, and it does also support one wire. Here's where it's a little different. It does have an edge computing component to it. So you can get into more advanced applications for those larger implementations like we were talking about earlier. It's got its own development platform. So it supports both Python as well as Docker on board, which means if it doesn't do it out of the box, your development integration team can customize the VG710 to operate any way you might want it to. Again, we are an Azure IoT partner. It is fully Azure IoT compatible, and it's an IP64 rated product. Here's a little bit more on these extensive integration interfaces that we have. We've got 6 digital inputs. Remember, this is the one that tells you if like a line is open or closed or a switch is on or off in the vehicle. We've got 6 analog inputs, so you're able to read, for example, a flow rate or a position of a door or something along those lines. It also has digital outputs, which means you're able to control switches, not just detect the switches there, but actually make something go on or off there in the vehicle. And then we've got the one-wire interface there. So, you know, again, one of the most common would be a Dallas key interface, but there's other one-wire options out there as well. It's also a fully featured router. So you've got 4 RJ45 Gigabit Ethernet on board. And then you've also got an RS-232 and an RS-45 on board. So you can integrate it to all kinds of other things that you may come up with as well. You've also got OBD2 and J1939 interfaces. You've got Bluetooth on board also. This is a powerhouse. And it's a powerhouse at a very attractive price. You've got your real-time status monitoring. Just, you know, with the OBD2 J1939, you've got real-time diagnostic data. You've got your accelerometer, so you know if there's harsh braking, harsh acceleration, dangerous taking of corners. So, for example, again, you know, you've got, let's say, a bus or a box truck, and they have a much higher center of gravity than your average car or pickup truck. The driver needs to be careful, and you need to know if they're taking those turns in a safe manner. That's what the accelerometer is going to kick in and tell you, is if there's dangerous driver behavior going on there. And then obviously we've got the real-time data acquisition of everything. And then again, we've got the ability to be integrated to a host of different sensors. I mean, Bluetooth, wired, Wi-Fi as well. Literally, you know, the sky's the limit. Your imagination is the limit to what this can be integrated to. Again, we've got open platform for customer development. We support Python 3, so you've got an onboard development environment there. You've got onboard development environment for Docker as also. So you've got really, really powerful computing options there for edge computing solutions. And again, your imagination and the imagination of your engineers is truly the only limit. And then we also have the Flex API, the REST API, and then a TCP UDP integration. So you can tie this into any telematics or IoT platform on the planet. It's just a question of picking what you need and how you want it to work. And from there, making it all happen. We've got a really, really easy integration process here. Again, it's Azure IoT Hub compatible. And then, like I said, we've got the customized Flex API. So that could be tied in, you know, MQTT servers, UDP and TCP to a telematics cloud portal. Whatever you need it to do, we can make it work with it. We can work with the engineers to make all of that happen. So at InHand, we've actually taken the philosophy of one size fits most. So what we're trying to do is hit different products where we can actually have a platform that serves a host of different use cases. So for example, if you look at the at the left-hand side of the screen, You've got the ambulance, the police cruiser, and the school bus. Those all would be prime use cases for the VG710 because let's face it, they may need that onboard computing capability, but they need broadband because they need to access data locally in that vehicle. You know, for the ambulance, it may be for gathering all sorts of different data off of machines that are on board, life-saving equipment, internet access for laptops, you name it. The same with the police cruiser. You may have onboard video cameras. You may need capabilities that send routing information to a third-party turn-by-turn navigation platform that's already on the police cruiser. On the school bus, IP cameras are actually becoming very common. You may want or need a mobile hotspot for the students to access internet while they're on the bus so that they can be working on homework, checking their email, downloading homework assignments, who knows. The point is, it's all capable here. And then on the right side, we've got more of the VT310 applications, where you've got the trucks, the heavy equipment, even perhaps a fire engine, but I could even see a fire engine using the VG710 as well so that they can have a wireless high-speed data hotspot for operations there on the ground where the fire engine is operating. And then obviously, you know, like I said before, we support all of the different auto and heavy equipment industry standards across the board, so you've got full compatibility there. Here's a selection of some of the applications that we're actually using or piloting right now for in-vehicle product applications. We've got large buses that are private transit, police departments, electric trains, you've got over-the-road trucking. We even have some over-the-road trucking applications where they're actually going, instead of the 310, they're going to the 710, because in this age of COVID, they want a wireless high-speed hotspot for the driver because he's spending more time in the sleeper berth and not having the option of getting out and doing things during his downtime, rest time. So it's a nice job perk that they're offering these drivers who are doing a lot more and going way above and beyond with all of the COVID situation, where logistics have been just a key part of helping us get through this whole mess. Obviously, like I said earlier, with ambulances, fire trucks, and heavy equipment. Here's a little bit more on the public transportation side. You know, we're looking at, you know, buses and motor coaches. They offer a lot of convenience for, you know, they're providing now, they need to be able to provide their customers with secure and fast, easy solutions for their onboard connectivity. You know, obviously they may want cameras. So you've got a picture here with the bus itself, and we've got a few IP cameras, and then that would connect to a digital video recorder to have an Ethernet connection, and then from there go out to the VG710 as well. So you've got real-time video information there, but then also accurate location. So some of these systems actually are having automated announcements coming up for each stop, you know, what the next bus stop that they're coming up may be, to alert the passengers of when it's time to get off. They're also monitoring driver behavior, and I'll get a little bit more into that in detail in a minute. And then they're also, you know, in some of these applications, using the GNSS navigation system to know if there's unauthorized use of the bus lane. So they're tying in with the cameras on the front facing to see that, you know, there's a car in the bus lane, and capturing what that license plate number is and reporting that back in. And then they're also synchronizing data to the fleet management platform of your choice. It's a really, really interesting, complex, and very useful solution. And then obviously over here I mentioned about the driver behavior. Again, harsh braking, harsh acceleration, dangerous turning, But then also there are some of these customers that they're tying it in to an alcohol detecting interlock on the vehicle, so that the driver has to blow into it, and it's a breathalyzer system before the ignition will actuate and allow the driver to turn on the vehicle to make sure that the driver is safe to drive. Particularly that more is on the motor coach side, but for a liability purpose, a lot of public transportation companies are beginning to look into that as well. And then obviously you've got location, the temperature, and then the passenger info as well. It may even be connected to a passenger counting system as they get on the bus. Like I said before, I can't say it enough times, the sky's the limit in what your engineers and your applications can be dreamt up. Effective logistics is a really, really ongoing challenge for ambulances. While it's in motion, they need to be able to upload patient information to a medical management platform so that they can have up-to-the-date, best-of-breed service, even getting to the point of having patient data being uploaded to the hospital before the patient even arrives, so that, for example, if the emergency room needs to have a crash cart ready, it's not just calling over a radio like they did in the old days saying, hey, we need a crash cart, we've got a hurt person, this. Now they actually can connect to all of these onboard systems. So it may be something on board where you now can broadcast back what the patient's blood pressure, heart rate, so on and so forth, any observable conditions, symptoms, so on and so forth, that the people in the back of the ambulance are gathering. They're able to collect all of that and provide it forward. High-speed cellular connectivity is absolutely paramount. And combining that with our industry-leading reliability, we've got a total game changer here. We've also got integration to a variety of devices on board, like I said before, so you could have that tied into any kind of sensor that's on board that vehicle, medical or otherwise. Again, driver behavior monitoring. Is the driver driving safely so that the patient gets there alive and the ambulance isn't in an accident? Believe it or not, ambulances are in an amazing number of accidents due to just the sheer adrenaline-based nature of the situation. Think about it. They're driving through red lights. They're going fast. They're having to weave in and out of traffic trying to get that person there. But still, we need to understand what's going on there so that they're doing the best that they can to maintain both the balance between safety and getting the patient there as fast as possible. Also, we can help them with task assignments, route planning, sending them navigation information to the next call, so on and so forth. I mean, it can even go into geofencing, real-time messaging, you name it. Now let's get into trucking a little bit. I have a feeling based on some of the folks here that I've seen on the list, some of you guys are going to be very familiar with trucking. So you're going to have access to all your critical onboard diagnostic information plus real-time monitoring of all of that diagnostic data. So you know what the RPM is, what the speed is, are there any check engine lights or other diagnostic error codes being thrown. You've got your GPS location, and then also through the Bluetooth interface, you'd have access to third-party applications such as electronic driver logs, which became mandatory back in 2018. And then you'd also be able to collect any and all of that data and push it back to any cloud-based platform of your choice. So, here we've got integration, you're showing the tracking, the fuel consumption, engine speed, mileage, maybe interfacing to a black box type scenario. You've got your acceleration, your angular velocity. That tells you if you're taking curves in a dangerous manner. Harsh braking, harsh acceleration, all of those things add up to danger. But then also on the other side, you've got the data flow. So you've got your driver behavior analysis, vehicle access, operational analysis. What are the engine hours? How many miles did Bob drive that truck yesterday, last week, so on and so forth, which that actually would get into even IFTA tax data, which could save the company a pile of money as opposed to just making a guess and reporting that information without a basis. Obviously, you've got your fleet management platforms, and then you could even have ERP or work planning, say, for example, in a cold chain environment application. And then we've got our heavy equipment platform. I know a lot of you guys have had experience in this who are on this call as well. So heavy equipment is a beautiful natural fit for the 310. You're collecting all kinds of useful diagnostic data such as fuel economy, engine RPM, engine hours. That's all readily available through the CANbus interface. All that's needed for maintenance, for hours billed on job sites, for anti-theft purposes, for operator accountability use cases. And the biggest thing I can reinforce on this is our superior network reliability coming out of that industrial automation environment where we had to make sure our stuff is up and running at all costs makes us the natural leader in this environment as we step into it. You're going to have that machine engine information all the time. If there's a cellular connection, it's going to be there. It's just going to work. So with this, again, we get into the CAT-M or CAT1 connectivity. CAT-M is a revolutionary new network upgrade to LTE that's been released here across, it's ubiquitous across the entire LTE footprint in North America. And what it does is it gives you a greater signal propagation in tough to reach areas. It's also much lower cost from the carriers than your standard LTE data connections. So what that does is that gives you a lot more options on the table to have something that's much more affordable for your larger use cases. Let's face it, some of these heavy equipment rollouts, between bulldozers, excavators, ditch witches, large roll-around generators, you may only have a couple of hundred trucks in your fleet, but then they're going to have all sorts of equipment on top of it. And the telematics industry guys know this. It's a better solution. It's a much lower data consumption standpoint. And so why buy a 50 megabyte data plan if you only need 5 megabytes of data per month? It's a no-brainer. Again, you've got the extensive IOs here, so you've got the ability to tie into anything. You're not just tying into the available CANbus information, but with all of those IOs, you can instrument into stuff there that's not on the CANbus as well. So that's going to give you legacy equipment capabilities there. It's going to give you the ability to just tie into things that nobody's thought about putting onto the CAN yet. It may be something as simple as a flashing light so that whoops, this guy's got an issue and he needs to deal with it. Or whoops, we've got a check engine light that's come on. And maybe you don't just want it to go back to the cloud. You want it to actuate a light there on the vehicle in a different way so that you're notifying the driver, hey, turn it off right now before it breaks and the real check engine light comes on. You may need to have something there that turns on or off the engine itself for the machine so that only authorized drivers can interact with the machine. That could be for safety purposes, or that could be part of your other requirements from an anti-theft standpoint. Again, you've got that 1200 milliamp hour backup battery. Not all heavy equipment is operated every day. That 1200 milliamp hour battery is going to give you the ability to see what's going on with that vehicle without drawing battery power off the machine itself. So you're not going to go out there in the middle of January and need to turn on a bulldozer and then realize, whoops, the other equipment killed it. Or, if you have to know where it is, I know everybody in the heavy equipment industries had that experience where they've had to drive out and jumpstart a bulldozer in January, and it is an awful experience if you've ever had to do that. IP67 protection rating. This is going to keep the dirt, the dust, the mud, the water. It's going to keep it all out. So this thing is going to live a long life on the piece of equipment you put it on. And then you've got our very storied history of building industrially ruggedized equipment. And that goes beyond just the IP67 protection rating. That goes down to a board level. We understand what it takes to build equipment that the PCB survives the high vibration environment of it. We know our stuff in that area, and we're going to make you happy. We actually had a few rental car applications as well that have been that we've started working on as well. So you're monitoring the vehicle data in real time. You've got location and diagnostic information for where it is, if there's any error codes that have popped up. Again, driving behavior is a big deal with that. Harsh braking, harsh acceleration, so on and so forth. Making sure that the driver is operating in a safe manner is a big deal. Here's a little bit more about a success story with a customer of ours called Tri-North. Tri-North is a large bus operator in Europe. Their requirements were fuel economy, plus also they needed to pull off the alcohol, it's called alco-lock data. That's a breathalyzer interlock where the driver actually has to blow into a little straw. A computer that's on board the vehicle there then determines, do I turn on the ignition so that the bus starts. They also wanted remote control and monitoring of the heating system. A lot of Tri-North vehicles operate in Northern Europe, where in the wintertime, in the bus heating isn't just a nice thing, but it's a needed thing. And you don't just want it to get too hot, and then you've got passengers that are uncomfortable as well. So they had to monitor that. And then obviously they needed connectivity to a centralized platform for monitoring GPS location, CANbus diagnostic information, and all of these third-party accessories that are being tied in. And then also passenger information. So they wanted to know how many passengers are on board, when are they getting on, when are they getting off, where are the passenger stops, so on and so forth. So here's a little bit more about the solution. There's an onboard control unit. There's an onboard monitor that says, where the stops are, how far away they are, when they're coming up. Driver awareness panel so that they know what's going on as far as fuel economy. Maybe he's on cruise control, so on and so forth here. And then this is the passenger counter that I was referring to earlier. This is a separate system that we're actually integrating to that's counting every passenger when they get on and off the bus. So then again, you can see there's the alcohol interlock, you've got the driver behavior. Are they driving according to the authorized speeds? Are they driving too fast? Are they driving too slow? Are they going to arrive on time or not? Engine status, do we have any error codes, so on and so forth. And then obviously notifying bus stops, keeping track of passenger info from the passenger counter, so on and so forth. And this is a little statement from Peter, who's the CEO of Tri-North. Says, as a supplier, I'm going to read this for those who might just be connected for the audio portion only. Says, as a supplier of advanced technology solutions for the public transport sector, we're very careful in the choice of our partners and system components. InHand and their VG710 therefore fit in very well as an easy choice for us in our latest project of over 130 buses connected to the Tri-North cloud services. So that's one application, and they keep buying more and more and more VG710s. They love them. And they said it's their favorite telematics device they've worked with so far. Here's a little bit about our selection guide. this is going to get into a little bit more of the details of knowing which product's the right product. I have a feeling some of you know which ones. Others may not have as big of a grasp. If something is confusing or you need a little bit of coaching or help later on, just call me. You've got my email, you've got my phone number. I'm happy to help in any way I possibly can. So here we've got the the VG710 and the VT310. We've got the 4G LTE cellular type. Obviously here with the VG710, we've got CAT6 for more high-speed broadband type applications. And then with the 710, we've got either CAT4 or CAT1, depending on what your needs are and what region you're actually in across the world. Most of the stuff here in North America is either going to be CAT1 or CAT-M, though, because you really don't need that additional broadband. It's more just about picking something that's going to connect to the right LTE bands for the part of the world where you're looking at tracking vehicles. The VG710 does have dual SIM, so you've got redundancy there. The VT310 does not. However, if you do run outside of the cellular coverage area, we do handle store and forward. So there is onboard flash on both devices, both the 710 and the 310, so that if you do lose cellular connectivity, the network, and then you come back on, all of the telematics data, the location data is automatically stored in flash and then sent bulk with time date stamps to it back to the cloud once you regain coverage. Obviously, you got your different I/O interfaces. On the VG710, you got 6 digital inputs, 6 analog to digital, 4 digital outputs, and then the one wire. You don't have quite as many on the VG310, but you probably aren't going to need it. You've got your one line for ignition. You've got 4. It's a dedicated ignition input line, separate and above and beyond from the CANbus ignition detect. That's going to give you a lot of redundancy on your legacy equipment. You've got 4 digital inputs, 1 analog input, and then you got 3 digital outputs for controlling things. So like, for example, honking horns, unlocking doors, turning on or off a flashing light, whatever the case may be there. And then again, you got your 1 wire for like a Dallas key interface. Both of them have Bluetooth. Both of them have GNSS and inertial navigation. On the VG710, you've got RS-232 and RS-485. On the VT310, you do have an RS-232 interface there. In case you need to integrate to some third-party application, RS-232 is a very, very well-known, heavily used interface for data sharing on legacy equipment and just unique IoT applications. You got Wi-Fi on the VG710, and you've also got VPN connectivity capabilities on the VG710. So if you need to send this data back, for example, and you're collecting let's say you're in a police vehicle and you're collecting in-cab camera information. You may need to have a VPN connection and send that back to a specific receptacle in the cloud somewhere that's protected and where data integrity can be assured, because perhaps there's legal implications to it. Both of them have CANbus, OBD2, and J1939. We actually just launched the 2 CANbus interface for the VG710 today, so that is new. And then on the VT310, you've got either OBD2 or J1708 or J1939, either single or dual CANbus interface. We've got the device manager, InConnect, the Smart Fleet interface, Azure IoT on the VT310, and we tie into all kinds of different platforms as well. On the VG710, we've got a 9 to 36 volt DC range for powering it. On the VT310, it's 9 to 48. Why? Because things out there that are in the heavy equipment world occasionally need the 48 volt range. And so that offers just a lot more flexibility to a lot more use cases. The enclosure is die-cast aluminum on the VG710, and it's a ruggedized plastic alloy on the VT310. The ruggedized plastic alloy is needed because all of the antennas on the VT310 are internal. both GNSS, cellular, and Bluetooth. And then obviously we've got the protection ratings. We've got the VG710 with IP64, and then the VT310 with IP67. Here's a little sneak peek at what's coming soon for our telematics applications. We have 5G LTE, 5G in the works for the VG710, and we also have CAT12 LTE coming soon, and that will support FirstNet. So that's going to support all of your first responder applications out there in the field, and LTE CAT12 is an amazingly fast broadband wireless connection. We also have other things such as additional new integrations to cold chain, to video telematics, and other features and functionalities there. And where we've got the VT310 right now, we've got a VT210, which is an OBD2 dongle style tracker that's coming soon. And believe me, we're going to have another one of these sessions when this comes out, because that's going to be something that a lot of people are going to be interested in as well, because there's approximately 23 million service vehicles that are light duty just in North America alone. So it's an area you really don't want to pass over. And then obviously they all will tie in to the InHand Flex API, or customized APIs to any third-party platform out there. Again, here's my email if you need it. Please write it down. Please reach out. Let me know how I can help. I've been in the telematics industry for 20 years now. So chances are, if you haven't dealt with it before, I probably have. If I haven't, I've been associated with something similar, and we'll find a solution. I'll find a way to help you. I am your trusted helper and advisor. Here's a little bit about the